What's good, math family? Today's video, we're looking at how to FOIL binomial expressions, but these binomial expressions are going to have variables and exponents. Stay tuned on how to properly FOIL. Starting this video out, I'm always going to suggest the box method because it makes this 100 times easier. So if you struggle, please use the box method. Biggest thing here is when we set up the box method is just making sure what's in parentheses stays together. So radical 3x and 3 can either go on the top together or on the side. What we can't do is mix it with what's in blue. We're going to get this totally wrong. And I've linked videos down below if you need help with the setup. So once we set this up, right, radical 3x goes here, 3 goes here. I go in blue, I put 2 here, and then I put 4 times radical 6x to the third. Yes, we could have simplified that x to the third, but just for the video's sake, we're going to keep all this simplifying to the end. And I love this method because we get to visualize and see exactly what we're doing. So 2 times radical 3x stays the same, right? So we get 2 times radical 3x. We can't simplify that. Then I go over to my second one, right? So now I'm looking at 2 times 3, which just gives me an answer of 6, right? Now I go down to the bottom expression. So I notice that there's no number in front, so 4 stays the same. Now I multiply what's under the radical. So 6 times 3 gives me 18, and x to the third times x to the fourth, is x to the fourth. And then in my last box, we're just multiplying 3 times this bottom expression. So we multiply 3 and 4 to get 12. Radical 6x to the third stays the same. Now, what I really like about this, again, is very easy to see. This stays the same. So we have 2 times radical 3x plus 6, right? This box is gone, that box is gone. Now, down here, we are able to simplify. So when I look right here, right, and let's get some more space. Where can I find some space at? Let's go right here. So when I look at 18x to the fourth, I could simplify this as 9 times 2 times x squared times x squared. And you don't have to keep this separate as x squared. But what? 9 comes out. This turns into 4 times 3. Radical 2 stays under the radical. We can't simplify it. X comes out as x. My other x comes out as x. And like I said, our 2 is under the radical. Now, when I simplify this, this turns into 12x squared. Let's write it under the box. Times radical 2. Now, I'm going to add that to my answer. Plus 12x squared radical 2. And then in the last box, now that I simplified this, the only thing I could simplify is this x to the third. So this turns into 12 times x times radical 6x. So now at this last step, we add 12x times radical 6x. And I'm sorry you guys can't see this. I know this is off the board a little bit, but this would typically be it. But before we go, let's double check our answers. Can't simplify anything under there. We can't simplify 6. 12x squared radical 2 we can't simplify. And 12x times radical 6x we can't simplify. And we also notice what? There are no numbers under the radical that are exactly the same, meaning we can't combine. So my final answer, let's rewrite this, would be 2 times radical 3x plus 6 plus 12x squared radical 2 plus 12x times radical 6x. So this would be our final answer, and this is why you need to use the box method anytime you're distributing, especially foiling, and you have radical expressions. Thank you guys so much for joining us today on Algebra 1 with Mr. Peters. If this video was helpful, smash the like button for us, comment down below, and let us know if you have questions or if there's topics that you'd like to see on our channel in the future. Thank you so much, Math Family, for continuing to watching and supporting our channel.